What's up? So basically, this is my solution to the Amazon hiring challenge that happened a few days ago. I think the deadline was yesterday, so I can make the video today. So basically, the first question was called minimum add. So you're given a integer number. You have to split it in two halves such that uh, the sum of the two numbers is minimum. So basically, if you look at this number, right, you can have one number as 24 and the second number as 35. You can also have one number as 42, 43, or like then you have 25. You can have different combinations, and you have to find the two combinations such that the what do you call the sum is minimum. So at first glance, maybe you might think, okay, let's use DP. We can like figure out all the different combinations and then find the minimum combination. But there's a much simpler way to do it. So, for example, let's look at a number like 7583. Okay, so one num two. So let's say we need to create two numbers, right? So and that basically the sum of those two numbers will be minimum when the numbers themselves are minimum. So how do you create those two minimum numbers? So basically you find the most smallest number in this number, and then you make it the least significant bit, or most you basically make it the first number. So for example, you have 6583, so your one number will be 3, and then your second number will be 5, and then again it'll alternate, and it'll go to 6, and then it'll go to, and then you'll have 8, and then you basically add those two numbers and you have the minimum value. So for example, if you have basically, first let's create a list from the number. So you have nums is equal to num for num in nums. Let's make it a string so we can like iterate through the this thing. And you have the this thing list of all the integers. Now we will just sort it. So basically, if we had like let's say 6879, you'll have it as 6789. And now let's create the two numbers, num1, num2 equals 0, 0. Now for I in range length of nums, we first like we'll check it if the value of I is divisible by 2 or not. Why do we do that? So we can just alternate. If I, and then you just return num1 plus num2. Yeah, that's pretty much how you're supposed to do it, and it passes all the test cases as well. The time complexity is since you have to sort it over here, it'll be of n log n, and the space complexity, I mean it's see, I think it's O of n because you have to, and n is basically the what do you call it, number of the size of the integer, yeah, when you convert it into a string. Okay, so now the second question was basically like you're given a array I, you're given an array, and then you're given a integer value k. You have to make it in such a way that a of I is less than or equal to a of I plus k. So basically, let's try to figure out what that means, right? So let's say you're given 2 comma 3 comma 4 comma 5 comma 6, and then your value of k is equal to 2. So you're basically comparing this with this and then this. So you see that 2 is less than or equal to 4, which is less than or equal to 6. So, and then you go again, and 3 is less than or equal to 5. So it is already satisfying the condition. So the number of changes that you need to make is 0. Let's say this is 2 now, right? So 2 is less than or equal to 4, is less than or equal to 6, but 3 is not less than or equal to 2. So you make this 3, and now it satisfies the condition. Now the minimum number of operations required is 1, right? So if you basically understood what I said right now, so what is happening is the array is getting split into a bunch of sub arrays such that they don't overlap with each other, right? So for example, let's say the value of k is 3, and then we have a bunch more, right? So essentially we are basically looking at values like 2, 3, 4, and then 3, and then 6, and then 4 again, and then 5, and then 2. So here, if you see, 2 is less than 3 is less than 5, 3 is less than 6, which is not less than 2, so we'll need one operation over here, and then 4 is less than or equal to 4. So this entire thing will take one operation to satisfy it. So let's add this in the test case as well. Then the value of k is 3, right? So we know the answer should be 1. How do we solve it now? I mean, kind of like, we know that we have to basically, we will be basically looking at a bunch of subarrays, so we know how to at least approach it till that point. So let's say we do something like look at this 2 3 5 3 6 2 4 4. So yeah, that's basically, now we'll mostly be creating a function to find how many changes are required in every subarray, right? So let's just call this function as define, and then we'll give an array and return 0 because we're still making it. And let's say we have a answer is equal to 0, and then we do I'm sorry for coughing, I have a disease. Yeah. Okay, so Now that we know, so basically we kind of like have to just modify this code such that we get the number of changes required, right? So what's the most what do you call intuitive thing to do right now? So let's say we have some sub array like 2 3 5 and then 7 and then also 3, right? So how many changes do we need in this specifically? One, right? So how do we know that? We can calculate the length of the longest increasing sequence, 1 2 3 4, and then we can minus it by the total length of the, what do you call, array, and then we'll get the length of operations required. So let's do that. N is equal to length of array. Let's create another function for this. Yeah. Cool. Now let's try to figure out how to basically figure out the LIS, right? So you can use DP for this. It'll take around O of n square, and then you're already doing O of k here, so it'll be O of k into n square, which might work, but it takes a lot of time. So you can use binary search also, and that's kind of what we'll be doing. So let's find the length of the array, and then let's create DP. And let's add the first value in DP as the first value in the array. God damn it. Okay, so now what we'll do is for I in range 1 to length of 1 to basically 1 to n, and now we'll basically check if the value of a of I is greater than or equal to the value at dp of I, right? So if it is, what we'll do is we'll dp of I is, oh wait, not dp of I, it's dp of length. I'll try to explain the code after. Or okay, so basically what we're doing is we're creating a dp. We keep for example, let's say let's do it for this value, right? So we have dp, and then we add 1 2 3 4 5, so we'll add 6 zeros, 3 4 5 6, right? And we make the first value as 2, and then we iterate. We see that 4 is less than or equal 4 is greater than or equal to 0, so we add 4, and then 5 is greater than 5, and then we add 7. Okay, so we have the length till 4 now, and let's do it till there. And then we'll increase the value of length. Increment the value of length. Okay, what if we get something like 3, right? So 3, I mean 3 is still greater than 7. Okay, my bad. So basically what we'll do is we'll try to find the index where we have to add this, and the condition that was supposed to be here was TP of length minus 1. Yeah, my bad. So basically what we do is first value we add it as 2, and then we see 4 is greater than 2, so we add it. 5 is greater than 4, so we add it. 7 is greater than 5, so we add it. And then 3 is not greater than 7. So what we have to do is we'll have to use binary search to find out where we have to add 3 here. So what we do is we will essentially use bisect right? So we do and we'll pass the TP, we'll pass the value, essentially we'll pass the lower limit and the upper limit. So now, for example, we use bisect right because we'll try to find 3, right? So where will 3 fit here? It'll be somewhere over here, so we'll add 3 here. And now TP of I, TP of the index that we found is equal to array of I, and then we basically just return length. Let's print the TP. Is not defined. I mean, we did get the correct answer, but why is this not printing? Oh, it is printing. We're just printing the wrong thing. Let's test it out on our value, which was 24573. 24573. So yeah, my bad. So what is happening is, since you're using bisect right, so it would be 2 and then it will be 3 here. So essentially what we are doing is we are trying to see that what is the longest length of increasing subsequence, and then we also try to account for, you know, when there are elements in the array that are like lesser than the increasing subsequence. There you go. So those two are the solutions, and both of them pass all the test cases. And I think the maximum score was somewhere around 200. So basically, like 100 for this question, and then 100 for this question. And then they both had 10 test cases. So I'm assuming one, so it's 10 per one test case. If you ask me, I don't know why exactly this question was 100 marks. It should have been somewhere around 30, and then this should have been like the rest, which I know the rest. It's 170, yeah. Uh, yeah, I don't know, like, I'm assuming, like, since you pass, if you pass all the test cases, someone from Amazon might call you back, but then again, Amazon's requirement for a SDE2 role is something where you have to be the CTO of Microsoft. What? Okay, whatever. Okay, cool. Bye.